So let's get started. A bit of an overview of what we covered last week and what we're going to be doing today. Last week it was more of a beginner level site grading introduction where we went over feature lines and grading tools, sites and surfaces, and it was to grade parking lots, ponds, and some other miscellaneous general grading. We got through most of that. There's just a little bit of cleanup, and we'll do that today. And then the bulk of what we're covering today is more intermediate level, so we're building on what we did last week. And this is covering earthwork and linear quantities, and especially what I call a dynamic parking lot subgrade surface. I want to apologize. The previous week I called this material quantities. We're more focusing on a subgrade surface to be excluding material quantities from which we can get cuts and fills. So that'll become more clear once we get into it. But so what we're going to go through today, I'm going to address just a couple comments. We got a lot of good feedback on the first webinar, and I responded to some of you with your very specific questions, but I wanted to mention a couple other ones here in the webinar that I think are valid for everyone. So we'll start with that, a couple minutes on that, and then we'll look at adjusting the design. We didn't quite get to that last time, but we put this model together. How do you then go and adjust the design, and how does that update quickly? And then it'll become evident why we put the model together in the way we did. And then we'll go ahead and we'll finish the miscellaneous grading. If you take a look down here, we haven't quite filled in some of this. We'll do some of that. We'll put a retaining wall on this southeast corner of the site. And we'll finish that up. And we'll address pond volumes. That's kind of an introduction to volume surfaces. We'll introduce use of the QTO manager and to quantify linear quantities such as curb. And then we're also going to address how to create this subgrade surface for a cut and fill. And the challenge that's going to be with this is that the subgrade depth isn't a constant depth from finish grade. It's going to vary whether we have a sidewalk, a heavy-duty pavement, or perhaps a standard duty pavement. So we'll show that in more detail once we get into Civil 3D. So that's the outline we're going to go through here. And with that, we'll jump right into Civil 3D. So a couple items that were mentioned, comments on last webinar. I just want to cover a few of those here. One was on just surface labeling, spots and contours. In Civil 3D, if you're not too familiar with surfaces, you build a surface model and then all your labeling is automatic. And it comes from a set of surface labels, and we can find those right up here in the contextual ribbon after picking on the surface. So I can pick on Add Surface Labels, and then I can specify different surface labels. For example, I can go to Spot Elevation and grab elevation only, Spot Elevation Style. I can click Add, and now anywhere I pick out here, I can label these spots. So if I label on there, I get 80977. I'm going to drop my scale down a little bit. And I can continue to label anywhere I choose. Okay, so these are dynamic surface labels. I pick on them. In fact, if I move them around, you'll see them update. So I drag it over here, you can kind of see 809.78. Anywhere I put this, it's dynamic to that surface. That's spot elevation labeling. Contour labeling equally as nice. Let's go to contour single, and we'll set the labels to proposed major labels and proposed minor labels. And the way single labels are meant to work is that you simply pick near a contour line, and it will label it. Any one of these I pick. Okay. If I set this to contour multiple, and I set those same styles, I basically get to draw a line across multiple contour lines, and it labels them for me. Now, one thing to note, if I pick on this line, I can move this after the fact. So I slide this around, the labels move right with it. Pretty handy. So you can kind of draw a number of these across your site as needed. What I recommend is putting in a number of vertices so you can kind of adjust it, because you can't add a vertice to this after the fact. Then again, not a big deal to delete it and drop it back in there. So a couple nuances to contour labels. Single contour labels and multiple contour labels are the same thing. If I pick on a single label, you'll notice I have 3 grips. What this is, in fact, is a line that just extends out, and then it becomes a multiple contour label line. So it puts a small little line in there. That can often explain why, if you have contours really close and you put in a single label, why it might label more than one contour line. And it's because this little line might be overlapping 2 contour lines. Some of the default settings when you put a contour label in here, if I look at the properties of it, it's defaulting to display contour label line as true. I set this to false, and when it's deselected, that line disappears. That's just the way it's set in the out-of-the-box setting. You can go to your command settings and default that to be off. Rather, your surface feature settings, you should set that. Other things like precision. Would we want hundredths place on a 1 foot contour interval? Absolutely not. That's going into the style and editing the precision in the text component editor. A little beyond the scope of this session, so we're not going to get into that. Another item that was mentioned, grading criteria. Let me bring up my grading creation tools. We had done things like creating this curb face and this curb top grading object. In fact, if I look at these in Object Viewer, it'll become clear what we were looking at again. So these are grading objects, and this is how I define my curb face and my curb top. That criteria comes from a predefined criteria set. And so in here, I created a criteria set called sites. And in there, I created a number of grading objects. If I take a look at this curb face, the way I created that one was to start over here and say create new. And so how I create that curb face one is like this. Let's call this curb face 2. Go to the criteria tab. And then I set the target as a relative elevation. So we're talking about a standard curb face. We're going to go up 6 inches. So a relative elevation of 0.5. And then a standard curb slope, at least in Minnesota, is a 0.33 to 1 slope. So that's that curb face that I'm defining there. If you wanted a vertical curb face, you'd want to put this at something like 0.001 to 1, and that would give you a near vertical face. Can't have completely vertical in Civil 3D surfaces. The last thing I do is lock all these parameters down, which means when I run this grading and create a grading object, it doesn't prompt me for these items there. It puts these in as defaults. And in fact, if you have these locked down and I went to go and change these, for example, if I were to change this curb face grading criteria, if I made changes to this, that would push to all the grading objects that are in this site already. So we don't want to do that. We want that curb face. But anyway, that's how we create grading criteria. There was another item mentioned about final sheet creation and plotting and all that. I don't want to get into that a ton of detail here. There's a lot involved with that. A lot of it comes down to the styles. For example, we wouldn't want to be printing this line. And so I've used object layers with wildcards to be able to turn those lines off fairly quickly. For example, if I can look at my object layers and drawing settings, I have feature line with a suffix and then an asterisk in here. So that will put objects, feature lines created in that site on that layer. I've got the same for grading criteria, or for grading objects. So grading objects are often a difficult thing to want to plot for many reasons, just because of these outside corners. You don't get a nice 90-degree, you get a rounded corner. So that's not necessarily something we can plot. But using those object layers with wildcards, I can very easily freeze that set of grading criteria. So it's things like that that allow me to quickly set up my drawing for planned production. What I would do when it comes to planned production, you wouldn't create the sheets in this drawing. You would be X-referencing and data referencing items from this drawing into a sheet file. It's kind of a standard practice, but again, a little beyond the scope of this class. So see topo grade dash pond and curb. That was the layer we froze. I can turn that back on, and that now comes back. So one of the final comments, final items that I wanted to address, and this is actually part of this second part in the outline here, the demo outline, which is adjusting the design and seeing how the grading models respond to that. So for example, we set up, if you recall, a drainage surface, and that drainage surface looks like this. So it was ignoring curb, it was basically the pavement, okay? So these grades, we're using this surface to set grades or elevations to our feature lines that are drawn at the gutter line of all of our curb. So in that case, it's these red feature lines here. So these feature lines pull elevations from the drainage surface, and then that allows us to create a curb and pond surface, and that looked something like this cyan that you see right here. There's my curb island, okay? So what we're going to do is we could make all sorts of changes, and we make those changes to our drainage surface. That's the key of how we set this up, and there's a lot more explanation on that in part one, but let's make a change here and see how that's reflected. If I were to grab this, which is a feature line dictating my drainage surface, if I were to grab this and make a change to it. So I pick this feature line, instead of sloping down at a negative 1.41, we're going to go down at a negative 2.2, we'll say. So when I do that, let me run that again, negative 2.2. Okay, so when I do that, this whole portion of the parking lot is modified or changed by that. So we should see curb islands be reflected by that. And so how we update that is to grab these feature lines and have that read from the drainage surface again. So drainage surface is turned off right now, but I can pull elevations from it from these curb lines. So I'm going to pick this feature line, go to select similar, and that will pick all three of my curb feature lines that I've created at this point. I can now hit escape, and if I go right to the modify tab, this is kind of a nice trick, we go to modify and run the elevations from surface command from here. And this will allow us to do an AutoCAD select previous command and to be able to pick all those feature lines at once. So if I run elevations from surface, I pull elevations from drainage, and then turn off insert intermediate, and I hit OK. Now here's the trick to it. I hit M for multiple, and then I hit P for previous. And you're going to see right in the command line there, it says 3 found. I was able to grab those 3 by doing that select similar. I can't run a select similar in the middle of this elevations from surface command. So a nice little trick to do that and not have to go out and pick 3 or in many cases 10 or 15 or 20 different feature lines. So those 3 are grabbed, I hit enter, and now as soon as it updates, it will assign elevations. You can see all those little triangles that show up. Elevations are assigned to every one of those vertices. So I hit escape. As we recall, my drainage surface and my pond and curb surface are pasted into FG, so a simple rebuild of this, and we'll see contours on everything over here update. Okay, so everything's very dynamic, the way we set this up, the way we built it. All these feature lines, these ones I select here, all these green ones that define that drainage surface, that's where you do your design modifications. That's where you slope things different directions, modify things to meet your design requirements. So let's go ahead and finish what we had started in part one, which is to fill in the grading here, and then we also have to fill in near the entrances a little bit. So if I look at my finished grade surface, we need to take care of this curb on the south side here, and we also need to fill in this area here. So I'm not going to explain in every detail, but we're going to use a similar process that we had done up near the building here, and we're going to do that between the pond and the parking lot. But before we do that, we have to build our curb along the south and east edge of the parking lot. So that starts with a create feature line from objects command, and then I go and pick that yellow polyline I have. Remember, this is my horizontal design, and I turn this into a feature line, and I put it in the same site as the other curved feature lines. I'll give it a curve style and assign elevations. Elevations will come from the drainage surface, and we will not put on intermediate grade breakpoints. So now I get a red feature line, and we have a few modifications for it. If I pick on the feature line and I go to my quick elevation edit, discuss this more in part 1, I have some elevations assigned along here, and those all look great. But over on some of these ends, I'm missing elevations because it's outside of my drainage surface. Similar to last time, we also need to put an elevation point at the edge or the limits of our drainage surface, and that's right here. So I'm going to put one right here. And I'm also going to put one any other place I have a grade break. Right here will be a grade break. We have that feature line defined in my drainage surface. I need to put a grade break right here. And we have a couple other ones here. These are where those other feature lines were. Then we have one at the extents of our drainage surface again. Okay, if I pick that feature line and run elevations from surface one more time, because I put those elevation points in there, those aren't reading exactly from the drainage surface. Those were just interpolating between here and here, for example. But we know that's not necessarily constant grade between here and here, so we need to assign elevations again. So I can pick the feature line, run the elevations from surface command, and pull elevations from drainage again. Go pick my feature line, and now we've assigned elevations. And similar to before, we need to set this portion of the feature line to tie into existing grade. So if I run quick elevation edit, pick this end of this feature line here, and then hit the S from surface command, and we'll pull elevations from the existing surface. Shows me down there 818.42. I'll hit enter to accept that. Now the only thing we have to do is to set the elevation of that point right there. That one's still sitting at 0 because it was outside of the drainage surface. I run the set grade between points. Pick right there, and set that elevation. Now that one is set up to be a constant grade. I'm going to quickly do the same thing on the other side here, and then we'll be on our way. In fact, we don't have any elevations or vertices between the edge of the drainage surface and where we want to tie in, so we really just need to set this one right here to the existing surface. So just setting that point right there to tie into the existing surface. All right, let's use our grading criteria and build a curb face on this. So same process as before. I'm going to run through this fairly quickly, and then we'll deal with the tying in there. I'm going to go pick my feature line and put a curb face on the grading side. Will be to this side an entire length. We'll continue on with that and do a curb top. Go to entire length. And we're going to put one more grading in here. We're going to put a little buffer instead of just daylighting from the back of curb here. We're going to put a little 2 or 3 foot buffer. So I'm going to do a daylight at %. Pick this back of curb, and I'm going to go the entire length. I'm just going to go, we'll say 3 feet at a negative 10%. So a question came in, does the set grade between 2 points command follow the feature line, or is it a straight line between the 2 points? The set grade between 2 points sets the elevations of all the vertices within the 2 points or the vertices that I picked. So I had selected that point right there, and this point right there. If I say set grade, and I pick those 2 points, it's going to set a constant grade between those 2 points and adjust that point to be whatever it needs to be. So moving on here, there's my small buffer. If I go ahead and put a retaining wall in here. So what does a retaining wall look like? I have a grading criteria defined in here. If I open this one up and take a quick look at it, it's set to daylight to a surface at a slope of 0.2 to 1. So that's just a slope of a retaining wall I've chosen. That's going to daylight down to existing grade. So let's run that grading. I need to set a target surface to existing grade. I'm going to go ahead and pick this. It's outside of my buffer and say no for entire length. And we're going to go put a retaining wall roughly about here. And so the grading is going to occur between my arrows here. I pick right there, and I hit enter for that stationing. And now it's going to daylight to existing. So let me go ahead and rebuild my FG surface, and you can see in 3D what we've created. Okay, so we're putting a retaining wall on this back side here. And we're daylighting right into existing. A lot of different ways to handle grading or retaining walls. This is just one example of them. So now what we're going to do outside of this retaining wall is we're going to put a daylight grading over on this end right here. And then we're going to run a transition between that retaining wall and that daylight grading. In this case, we probably would have need to run the retaining wall a little further, but for this illustration, it's going to work fine. And we're also going to put a daylight grading right up by this entrance here, and then we're going to infill in between here, similar to what we had done up by the building. So I'm going to do daylight 3 to 1, create grading. I'm going to pick this buffer here. We're going to go from roughly about here to right there. And that's just simply going to tie into existing grade. I'm going to do a similar thing up here. I'm going to go from the start. I'm going to stop short of my retaining wall. My retaining wall is right here, but I'm going to stop maybe 10, 15 feet short of that and then run a transition in between the two. So I'm daylighting right there, and then if I go and select my create transition command, if I have two gradings of the same type, both of these are daylighting to surface gradings, I can pick on the feature line they're connecting to, which is this one, and I can pick between the two grading objects, and it will run a transition. And so it's blending between that 0.2 to 1 retaining wall slope and the 3 to 1 daylight slope. So if I go ahead and rebuild my surface now, we will see those contours show up in there. With these steeper grades here, I'm going to turn down my contour interval. We're going to go to a 2 and 10 foot, show fewer contours. All right, what else here? Got to finish up down here. Okay, we can't really put a grading between any of these items here because the grades are kind of random, and it's like that grading between the building and some of the parking lot, like up here, what we saw. So we're going to do that same kind of thing. We're going to draw feature lines and then place an infill in the closed area. And I like to start with polylines because it gives me some control on that exact grading limit. So I'm going to draw 2 polylines here. Something like that. And we're going to turn those into feature lines, and we're going to put these both into the curb and the pond site. It's the same site that all the pond grading and all the curb grading is in. We'll give it a style of daylight. We'll hit OK. And we'll pull elevations from existing ground, and we'll also insert intermediate grade breakpoints. Once I have that in there, I can now put an infill in this area. You see that little diamond show up, and then once I go ahead and rebuild my surface, my finished grade surface, you'll see those contours show up. So a nice way to just fill in there. Oftentimes it doesn't quite triangulate the way you want, and you get contours that look kind of like this. And what we can do is to draw another, we can draw another polyline in here, and we'll turn this into a feature line. So let me kind of show this. I want to control a bit of a swale through here. So if I draw that polyline in here and I make it a feature line, and I put it in the same site, and I pull elevations right from pond and curb, okay? So we don't want to change the elevations much, but we want to kind of massage the grades a little bit. So I'm going to pull elevations from pond and curb, and hit OK. And as soon as I do that, the grading object that's in there, this one right here, that's going to start interacting with that feature line. And right off the bat here, if I rebuild FG, you're going to see it starts controlling those contours. So I'll make one change here. I'll change this elevation. It's at 811.26. I'll go down to 810 just to kind of illustrate some of the control we have here. I brought that point down. If I rebuild my FG, you're going to see those contours respond to that. Okay. I can spend a lot of time massaging this more and more. I would want to do a similar thing over here to control those contours a little better. Okay, one final thing I want to mention before we continue on here. You get kind of squirrely contours like this. There's a nice thing called surface smoothing. And if you just have certain areas like this, it works great to do this just in those key areas. And so what I'm going to do is draw a pretty crude boundary here just to illustrate the point. And I'm going to run a smoothing on this area. So I'm going to pick the surface. This is on my FG, my overall surface. I'm going to run a smooth surface command. So you don't want to do this to the entire surface. You just want to do it to certain areas where the contours are a little messy. So I pick on this polyline, that's my smoothing boundary, and I'm going to do an interval of 5 feet for both of these. When I hit OK, right off the bat you can see those contours respond better. Okay, I just threw a few things together here, but this is a really nice way to get your surface to look a lot better. Let me point out one quick thing that it does. If I look at the surface in Object Viewer, take a look at the triangles in this area. What it's actually doing is dropping a 5 by 5 foot grid in this area. Might be a little tricky to see. But it's dropping a 5 by 5 foot grid and basically chops up all those triangles. When you have smaller triangles, you get better contours. So there's a limit to it though. Don't do it on your whole surface. Your drawing will be huge. Don't need that many triangles, just in areas where the contours are a little screwy. All right, I want to show one last item about filling in this area over here. Okay, we need to tie this in. We basically have everything graded the way we want. We just need to fill it in. So what I'm going to do is I'm going to use a feature line, and that's this magenta line right here. I have that just drawing as a polyline right now. I'm going to turn that into a feature line and put it into a new site, and we'll call these FG break lines. We're going to assign elevations to it, and then they're going to come from existing grade. Okay, I'm going to take that feature line, I'm going to add it to my FG surface as a break line. So I'm not adding it to the pond and curb surface. We don't want to do that. We want to add it to the FG one. And when I do that, it's going to triangulate right away to that. And what we're going to end up still often is a little gap in here. This is where what we call show boundaries comes in. So I go to boundaries, and I can run a show boundary on this. So when you do show boundaries, you want to turn off non-destructive. And then I have a simple polyline drawn right here. You can see that highlighting there. And when I pick that, it basically allows it to just fill in that area. Okay. So our grades aren't quite finished there. The driveway's a little steep, but you get the idea of how we model this stuff, how we put it together. So let's continue on. Let's look at some of these quantities. Let's look at pond quantities. Well, in the case of this right here, let me go ahead and freeze this boundary layer. I've got a feature line here that my pond was built on. If you can draw that to represent your pond capacity or your normal water line, it's real handy to be able to take that then and add that feature line as a surface as a break line in a separate surface. So I'm going to add it to a new surface, and we're going to call it pond top. And just so we can see what it is, I'm going to give it a style of contours and triangles. And we're going to add this break line in there. I'm going to put some supplementing factors to get a little more detail in there. And what we end up with is just a very basic flat or top of water or normal water line surface. I have that surface. I have my pond and curb surface. I can compare those two now using the Analyze tab in the Volumes dashboard. So if I pick on Volumes dashboard, I can run this, and this one we'll call pond volume. We don't need to display this, we just want to see the quantities. So we're going to set it to no display. The base surface is going to be pond and curb, and the comparison is going to be pond top. It actually doesn't matter which is which, because it's going to give you one number, and that will be right over here. There's our capacity, 260 yards. Okay, that's pond volumes. Okay, there's other tricks. If your normal water line isn't that feature line, you can extract user-defined contours is a nice way, and then use that to create a pond top surface. Let's look at linear quantities. A great way to do this, we want to get quantities from our feature lines here. In this case, I'm going to use these 4 red feature lines that represent our curb. I want to add up my curb quantities. How do I get that? This is best accomplished through the QTO manager. I type in QTO manager. It's also available on this button right up here. And what you have to do is you have to load a QTO file. So I'm going to say open pay item file and browse to a CSV. Now what I have right here is the getting started one. This comes with out of the box Civil 3D. It's buried in your program data folder. So I can open that, and what that is a CSV with 3 columns in it. It's got pay item, it's got a description, and it has unit type. So this is referencing a CSV now. I can come in here and I can search by, let's type in curb, for example. There I have curb concrete. Let's go out here and let's pick these feature lines, say select similar. All 4 of them are selected. I come into my QTO manager and say assign pay item. I click on that and it assigns the pay items. I know they're assigned because when I hover over one of these feature lines, now in my tooltips it says pay item assigned. Okay, and I also have some options up here. It might be a little tough to see through the webcast, but I have highlight objects with pay items. So if I click on this, it'll highlight those red lines. The highlighting is not the greatest, but it's there nonetheless. Someone asked, can you show us the CSV file? Absolutely. Let me open up Windows Explorer here. We'll go to C, we'll go to Program Data, we'll go to Autodesk, we'll go to C3D 2015, we'll go to NU, go to Data. They really bury this way far in here. Pay item data, getting started, and there's a CSV. And if I open this in Excel, it's a pretty straightforward file. It's these first 3 columns that it reads. Okay, so you can have other items in here for unit price and things like that, but it's these first 3 columns that it would read. That's what comes into Civil 3D. All right, let's go back to Civil 3D. Once you assign the pay items, you have quantity takeoff. You have the button right here, and you also have takeoff right here. So if I hit the takeoff button, and I say report type of summary and compute, it's going to read everything in the drawing that's been assigned a pay item. And if I set the summary type to HTML, I can get that readout. Okay, I can save this out as all sorts of file types. I could also say draw, and when I run the draw command, it gives me a small AutoCAD table. So let me close out of the QTO commands, and I can put that table in here. Okay, so this is a takeoff. It's not a dynamic table. It's a one-time read of the data in your drawing. Now this final item I want to show is to create a subgrade surface. And to create a subgrade surface, and many times it's not just a simple offset of our finished grade surface because we have different depths. The reason we want to create a subgrade surface is because we want to calculate cuts and fills based on that. Let me simplify things a little bit by freezing some of these grading objects and other feature lines. Okay, in my drawing I have some layers in here, and I'm going to turn those on now. And all of these are just basic hatching, and polylines. And what I have here, you see three main hatch patterns. Be a little easier to see if I turn my surface off for the moment. I have three main areas. This is heavy duty, okay? I have a 1.5 foot subgrade cut in this area. So from finished grade to bottom of subcut is 1.5 feet. In the magenta area, I have 1 foot. In this sidewalk area, I have 8 inches. What I've done is I've set these polylines for those areas. This one right here, I have a yellow polyline. That's my hatch boundary. I've set the elevation of this to be 1.5. So the way this works is we're going to first build a surface with polylines in it whose elevations are set to the depth of the subgrade itself. Okay, and we're going to make a number of surfaces to do this. So I'm going to keep going through it. It'll make sense as we get it together here. So it's quite a workflow, but it'll make sense once we have it completed. So what I'm going to do is I'm going to take these polylines, all three of these, 4 of these rather, these are all going to be break lines in a surface. So they're just plain polylines. So first thing I need to do is create a surface. And we're going to call this subgrade depth. Okay, this isn't our final subgrade surface. This is one of the surfaces we have to create to get there. So I create a surface, and then I expand that, and I add break lines. My break lines will be all those polylines I had just shown you. Okay, that surface shows up. I'm then going to throw a boundary around this, and I have a simple polyline drawn as well here for a boundary. And that polyline is just simply a polyline drawn slightly outside of my different subgrade depth closed polylines. So I'm going to pick this surface and add a boundary to it. It's going to be an outer boundary. We'll pick this white polyline. Okay. So let's take a look at this surface in Object Viewer. What are we creating here? This is a surface with break lines in it. The elevations of it are very low because they're made from polylines that have elevations of 1.5 in this area, 1 foot in this area, and then 8 inches in this area. But if I look closely, I can see kind of a face there. If I go to conceptual, you can see that a little better. The area right here is 1.5 foot depth subgrade. Right here is 1 foot. Okay. The polylines This is higher right here because it's elevation of 1.5. This is elevation of 1. Okay, so this is our subgrade depth surface. Now here's the trick. Let's turn on our FG surface. If this is my FG surface, and I also pick my subgrade depth surface, we're going to go into Object Viewer again. Up here is my finished grade surface with elevations in the 800 range. Here's another surface with elevations in the 8 inches or 1 foot or 1.5 foot range. What we're going to do is we're going to make a volume surface comparing these two. And what a volume surface is, it's not actually something with any kind of depth to it. It doesn't have a thickness or anything like that. It's simply a surface whose elevations are the difference between two other surfaces. So let's take a point right here, the corner of this parking lot. The elevation right there is in the 800 range. That exact same corner down here is 1 foot. Okay, if I make a volume surface, the difference between those is going to be 800 minus 1 foot. It's going to give me an elevation in my volume surface of 799. What that volume surface is, once we create it here, is just another surface. It doesn't have thickness, like I said. And what we're going to end up with is a volume surface in this area that's 1 foot below finished grade, and in this area it's 1.5 foot, and then in these areas it's going to be 8 inches. So let's go make that volume surface. I'm going to create a surface. It's going to be subgrade volume. And the type needs to be tin volume surface. My base surface is going to be my subgrade depth. That's the surface down at elevation of 1 and 1.5 feet. My comparison surface is my FG surface. I hit OK. And now I get another surface here. Let's take a look at all three of these surfaces in Object Viewer, and we'll understand what's going on here. Let's go to a 3D view. Okay, sitting down here is my subgrade depth surface with polylines of elevations around 1 foot. And up here is my finished grade surface. Let's go to a 3D shaded with edges. Okay. If I zoom in here, let's take a look at this from this side. Better yet, let's stay at that one entrance there. If I zoom into this area right here, okay, the red, couple grades and elevations are off, but we'll understand the point of it here. The red surface is my finished grade surface. The gray surface is my volume surface. That's the comparison of the red and the subgrade depth one way down near 0 elevation. So a volume surface is not anything with thickness, like I said. It's another tin whose elevations represent the difference between two other surfaces. Let's escape out of here and look at just the subgrade surface and see what we've ended up with. This is my subgrade surface right here. This represents what I'm cutting down to or filling up to before I put my import materials down. So in areas where the curb islands are, I don't need to cut down as far. Let's look over here. We'll see the difference. Remember we said that drive right through the parking lot was heavy duty pavement? My subgrade goes down 1.5 feet right here. It goes down 1 foot right here. And here, it's just enough, well, that's 1 foot as well, but we could have gotten more detailed with our subgrade depths if we wanted, and we could have put a 6-inch polyline there to represent perhaps 6 inches of topsoil. So this is a subgrade surface that we can now use to calculate quantities from. Let's illustrate this in a different way. Let's turn some of these surfaces off. So that was the subgrade surface off. That is the subgrade depth surface. Let's also turn off some of these hatches here. We don't need these anymore. And then we're also going to turn on some of those feature lines and some of those curb gratings as well. And what I'm going to do here is I'm going to make a couple of viewports, and we're going to make a profile view through this, and we're going to compare that finish grade with the subgrade surface so you can see again just what we're creating. And then we'll actually go and we'll make changes to the design, and we'll see how that's reflected in there. So this is going to give us a real nice perspective. If I pick this feature line and I go and do a quick profile, what we want to see is FG. I'm going to set that to a design style. I also want to see subgrade volume. We'll set that to existing just so it looks different. A profile view style of profile view. And then I'm also going to draw the 3D entity. That means draw the feature line in the profile view as well. So I hit OK, and we'll put this over here. Now let me go to a couple viewports so we can see everything that's going on here. Okay, so on the top we've got our profile view, and in the bottom we've got our plan view. This red line right here is the feature line. Okay, it's salmon. I gave it a different style. This line right here is the feature line. The blue line is my finish grade. The red line is my subgrade surface. And now you can see there's that 1.5 feet, there's that foot depth, and there's the 8-inch depth. Okay. Now the limits of some of those subgrade depth polylines, those can be adjusted depending on how you're excavating around these large curb islands and such. But the idea is that we can link this stuff together and make it all dynamic. So what I want to do here is I want to make another change to the design. Let's change this exact polyline. Let's pick this polyline, insert an elevation point right about here. We're going to put a grade break right there. So I've got a grade break right there, and then instead of grading away at a negative 1.79, that's what you see there, we're going to pick that and we're going to go to negative 2.5. And as soon as I do that, you see in the profile view that feature line adjusting. Okay. Now what is that feature line? That's a break line on our drainage surface. If our drainage surface changed, we need to update our curb lines. So to get finish grade to respond, I simply need to go pick the feature lines that are affected by that change in the drainage surface. I'll pick this one, go to elevations from surface, and pull elevations from the drainage surface. That's the one that this break line is dictating. Then I'll hit M for multiple, and I'll go and pick that curb line and that curb line. Again, these are flow lines. I hit enter, and now all of my pond and curb surface and the grading objects that contribute to it have updated. And what we need to see, what we need to do for an update in our profile is we simply need to update the FG surface. That's out of date. Remember, this FG surface is a composite of the drainage surface and the pond and curb surface. So if I rebuild this, you're going to see that now update. So my entire FG surface just responded and updated to that as well. Now what about my subgrade surface? Well, what is the subgrade surface? The subgrade surface is the difference between FG and the subgrade depth. The subgrade depth doesn't change. I still have 1 foot, I still have 1.5 foot depth of subcut in those areas. The only thing that's changed is FG. Well, if FG is updated, I simply need to rebuild this, and once I do that, do I need a regen? There we go. Now the red line adjusts as well, okay? So my subgrade surface is dynamic to my finish grade surface. My finish grade surface is dynamic to my drainage surface. Everything's kind of going back to that drainage surface. That's where you do your design. So the whole point of all this, what is the point of all this? We could have taken FG and pasted it into another surface and then done a raise and lower in it. The point is when we have different subcuts, 8 inches, 1 foot, 1.5 feet. That's why we build it this way. We're taking advantage of volume surfaces, and that they're really just a difference between two surfaces. Now, one final thing here, if we want to get our excavation limits to subgrade based on existing grade, we can't actually compare a volume surface. We know that because it has this little volume icon here. So we have to make one more surface. And this one I'll call subgrade. And what subgrade needs is subgrade volume pasted into it. Subgrade volume is pasted into it. And it's the exact same thing now. Okay, so subgrade volume, if I set that to contours and triangles, subgrade volume is the same as subgrade. So the only reason we have to paste the subgrade volume surface into a regular tin surface is because it's only with regular tin surfaces that you can do volume comparisons. What we need to do now is to take this surface, compare it to EG. That will give us our cuts and fills. So let's make one more surface. This one will be actually let's not do it here. Let's go from the Analyze tab. So Volumes Dashboard right up here. Volumes Dashboard, we'll make a new volume surface. We'll call this subgrade versus EG. And we're going to compare the EG surface to the subgrade surface. Notice that subgrade volume is not in here. It doesn't show up. I can't compare a volume surface to another volume surface. I have to paste that volume surface into a regular tin surface. So that's why that final step before this was required. I could put cut and fill factors in there, but I hit OK, and now I get cuts and fills. And of course, this is all dynamic as well. Let's do one change again, and I'm going to explain through the process again what's happening as we do this. We've got cuts and fills, okay? We've got a number of surfaces over here. Again, let's go back to the drainage surface and make a change to its elements that contribute to it. That's these feature lines right here. This is one of them. It's all those other base feature lines. Basically all of these ones you see right here that are highlighted, okay? Let's just make a simple change. Again, pick that same feature line, and we'll adjust this. Instead of the -2.5, I'll go to -2. And when I do that, of course, you'll see it in profile view. Okay, that change only reflected the drainage surface. Now to have the FG surface respond, we need to update the feature lines in the pond and curb surface. That's these red feature lines. I pick on this, I pull elevations from the drainage surface, and I do M for multiple, and go and pick the two feature lines affected. I go ahead and run that, okay? That brings my curb lines up in this area. It also updates this berm behind back a curb. It also updates the retaining wall. All that stuff is updating, okay? To see that change in my profile view is to simply now rebuild the FG surface. So I hit rebuild, and now you're going to see that change right here. Okay. To see the subgrade surface change, I need to update the subgrade volume surface. I rebuild that, and now that red surface updates as well. And then finally, my subgrade versus EG, that one is out of date. That's my subgrade versus EG volume surface over here. This is my final update. I hit refresh or rebuild right here. That will rebuild, and I get new cuts and fills. Okay. So this is why we set it up this way. It's all about dynamic relationships between all these surfaces. I created, what do I have over here? 4, 5, 8, 9 different surfaces in here. We talked about in the first part about turning down tessellation spacing and turning surfaces off. Okay, you're making a lot of data in here. You have to keep that data turned off to make this work well. So that's the gist of what I wanted to show today, and it's all about pulling quantities out of there. So we use QTO Manager. We use basic volume surfaces for a pond capacity. And I'm going to use a series of surfaces, volume surfaces and tin surfaces, to generate a dynamically linked subgrade surface over here. And how much you want to quantify what you need for your subgrade surface, that's all based on those polylines. And those polylines are basically just offsets from what I created for my curb lines there. Just a little bit of plain AutoCAD work there.